Hello students and welcome to yet another video on foundation course for business statistics, and in continuation with previous video on permutation and combination. In this video we plan to look at one of the numericals. So we have already seen the formula for permutation as well as formula of combination. Now we'll apply those and we'll understand the details in terms of what each element in the formula means. Okay, so the best way is to go through one of the example. uh, so let me put across a scenario. Suppose we have a group of 15 employees. In how many different ways can we select one project manager and one team leader from 15 employees? Okay, and in how many different ways can we select a team of 3 members from 15 employees? So this is what is asked to us. Suppose we have a group of 15 employees. Then first, in how many ways, in how many different ways can we select one project manager and one team leader from 15 employees? And second, in how many different ways can we select a team of 3 members from 15 employees? First of all, nowhere we are given whether we want to uh, calculate permutation or whether we have to calculate combination. So reading the problem, you need to identify whether it's a permutation problem or a combination problem, right? So if you remember in our previous video, we did mention that when it comes to permutation, order matters, right? Whereas when it comes to combination, it's purely selection. Order doesn't matter, right? So which amongst these two is permutation and which among these two is combination? So if you see the first one, we have to select one project manager and one team leader from 15 employees, right? So if employee 1 is selected as project manager and employee 2 is selected as team leader, then this will be considered as a different element if employee 2 is selected as a project manager and employee 1 is selected as a team leader. So these would become two different elements, and hence the point 1 is permutation, whereas here we purely have to select 3 members from 15 employees. So doesn't matter, there is no order. So this becomes combination, right? So let us apply the formula, and we know NPR is equal to n factorial upon n minus r factorial. So what is n? N is equal to 15 because it is group of 15 employees. And what is r? In case of first, r is 2 because we want to select 2 employees from the group of 50 employees where one is project manager and other is team leader. So r is 2. So we will have to 15 factorial upon 15 minus 2 factorial, that is equal to 15 factorial upon 13 factorial, that is equal to 15 multiplied by 14 into 13 factorial upon 13 factorial. This gets cancelled. So our answer to first question is 15 multiplied by 40. This is the final answer. Whereas second, NCR, where I have n factorial upon r factorial into n minus r factorial. We know what n is, we know what r is. So we have 15 factorial upon r is 3 factorial multiplied by 15 minus 3 is 12 factorial, right? So 15 into 14 into 13 multiplied by 12 factorial upon 3 multiplied by 2 multiplied by 1 multiplied by 12 factorial. We deduct these two. We have 1's 5's, 1's 7. So 35 into 13 is 35 into 13 is the final answer for point number 2. So basically in this video we tried to understand how we can differentiate uh, or how we can identify whether we need to apply a permutation formula or a combination formula, right? A scenario was given to us and two things were asked to be calculated, and we identified. So based where we found that arrangement or order was essential, we applied permutation, and where we found that order or arrangement wasn't essential, it was purely selection, we used combination. I plan to end this video here. Thank you so much, and in next video we'll look at more numericals. Thank you.